Good morning, everyone. Okay, we are in section 2.5, and before we continue, just let me make a important announcement. Okay, our third exam is on Friday, right? So we won't finish this section. So we'll do one more example from this section. Okay, so I want every one of you to practice these three examples. Okay, the very first example from this section 2.5. Okay, this is the very first example that we did, right? So I want every one of you to practice this example. The second example, we did one more example here yesterday. So this example and one more. So this is the one we will do today. Okay. So from this section, I want you to practice only these three problems. Okay. If you have something on your review, you are not required to do. So we'll do one examples, and the remaining for the remaining portion, I will just record the videos and I will upload on the link. And the due date for this section has been extended. Okay, so I have extended the due date for this section. So you can do the homework for this section after giving your third exam. Okay, you can. So it's on should be like on Sunday midnight. So we have our exam on Friday. So you have like 2 days to complete this section, and I will upload the videos for the remaining section on the link. Okay, so only three problems that you're gonna practice from this section only. Okay, and once we finish this example, we'll start review, and we'll review for tomorrow also. Okay, so make sure only to practice these three. It means you will have one example, okay, on your exam out of these three. And there is one more question on your exam 3 which we will not cover today. Okay, so I have provided you the hints. If you do, you get the credit. If you don't do, you still get the credit. Okay, so there is one problems that is from the topic that we will not cover today. Okay, I have also given you the hint. If you can try, okay, and if you don't try, you still end up getting the credit for that specific problems. Okay, any question? Okay, if so, now let's go and finish this example, and after this we'll start the review for our exam 3. Okay, so here we have this table, and this table gives the value of commercial printer at 2 different times after its purchase. Okay, so we have this table here. So after 2 years of purchase, the value of a printer is $10,000. Okay, and after 3 years of purchase, the value of a printer is $9,000. Okay, so this is given to us. We are asked to find the input and output variables for this table. Okay, now what would be the input and output for this case? One more time.
The input the years and the output's the dollars.
Okay, yes. So we input the time, right? And the output we get is the dollar. Okay, so here for number A, so our input is T. So T is the input and T is the number of years. Okay, T is the number of years after purchase of the printer. So this is our input, okay, and our output, so is the value of the printer. Okay, so let's call V, or we can call D. Okay, so we have V as the output. Okay, so this is the input. Okay, so this is input, T is the input, and our V is the output, and this output is the value of printer. So we substitute the numbers for T, and we can find the value of printer. Okay, so this is for part A. So these are our input and output. Okay, now in number B, we need to express the value of the printer as a linear function of the number of years after its purchase. So now we need to write an equation, linear equation for this table. Okay, and for writing a linear equation, we need a slope, right? And we need the y-intercept if we can, or if not, we need a point. Now from this table, we can take 2 points since this is our input. Okay, so this is our input. Okay, this is our input and this is our output. And input and output in an order pair is a point, right? So we have 1 point, 2, 10,000. So this is 1 point, and the second point is 3, 9,000. This first element is the input. Okay, 2, 3 are the years, 10,000, 9,000. These are the output, and for our case, V is the output. Okay. Now from these 2 points, we find the linear equation. In order to find the linear equation, we need to find the slope at first. So let's find the slope for these 2 points. So finding slope means our M is, what is slope? Slope is y2 minus y1 over x2 minus x1. So let's call one of these points as x1, y1. So let's say this is x1, this is y1. And let's call our second point this as a x2, y2. Now we substitute here. So what is our y2? Y2 is 9,000. Okay. So our y2 is 9,000 minus y1 is 10,000 divided by x2 is 3 minus x1 is 2. So we have 9,000 minus 10,000. So we have negative 1,000 divided by 1, and this is negative 10,000, sorry, 1,000. So negative 1,000 is the slope here. Okay. Now we have a slope. Now what do we use to find the linear equation? We have the two options, slope intercept form or a point slope form. Which one? Point slope form. We don't know the y-intercept here, so we have to use the point slope form, and our point slope form is y minus y1 equals m times x minus x1. Okay, so we have y as it is, y1, so our y1 is 10,000 equals our slope m is negative 1,000 times x minus x1, that is our x1 is 2. Okay, now let's get rid of this negative 10,000 from left side. So we're gonna add 10,000 on both sides. So here these two cancel. We have y equals to, we can distribute this 1,000 times x and negative 1,000 times negative 2. So we have negative 1,000 x positive 2,000 plus 10,000, and our y is negative 1,000 x plus 12,000. So this is the linear equation. Now in our case, what is y? So y is the output, right? In general, we use y for output. But in our case, what is y? So what is the output? So that's what we had in number A. Our output is V, right? So our output is V of t, okay? V of t is our output, equals negative 1,000. Our x is the input in general. But in our case, what is the input? T, right? So we're going to substitute t for our input. So we have t plus 12,000. So this is the linear function for this table, the table that we had. Okay, so x and y, these are the very general. Okay, y is the general for the output and x is the general notation for the input. Now for our specific example, we have to use the v of t for the output. That's what we defined in number A, and our t is the input. Okay, let me know if you have any question up to here. Okay, as I mentioned earlier, we did 3 examples including this, and out of these 3 you will have 1 question, and the points gonna be should be like a 10 points or maybe like a 15 points. So make sure you practice these 3 examples from these sections. Okay, so now let's go and see what we have in number C. Okay, now before that, why we have a negative slope here? What does that mean?
Going down.
The value of printer is decreasing, right? So our slope is negative. That's right. Okay. Now for number C, we are asked to find. Okay, using this function from in part C. Okay, now that's what we had in part B. So we use the function from part B and find the original purchase price. Now let me write down the function one more time. Our linear function for this is v of t equals negative 1000 t plus 12,000. Okay. Now here, what is v of t? V of t is the value of printer after t years of purchase, right? And what is t? How did we define the t? T is the number of years after purchase, right? And in number C, we are asked to find the original purchase price. Now, what does that mean?
In the first part, we set t to 0.
And what is the reason for that?
That's the origin.
So when we purchase the very new printer, the number of year after purchasing is 0, right? So in order to find the original price, we substitute t equals to 0, and solving this output, this linear function, give us the original price. Okay, so we substitute t equals to 0 for original price. Okay, so we have v of 0 equals negative 1000 times 0 plus 12,000, and this is equals to $12,000 is the original price for this printer. So the original price was $12,000, okay, and it decreases by $1,000 every year. So whenever you are asked to find the original price, the time, the t is the number of years of purchasing the printer, and when we purchase, at that time our t is equals to 0. Okay, so this is the original price. Okay, let me know if you have any question. All right, so let's go to the last one. So we have number D, and in number D, we need to find, okay, so assuming that the value of the printer is a linear function, that's what we had in number B, we need to find when will the printer's value reach $0. So we need to find, so here we need to know when will the printer's value reach $0. Now what are we asked to find?
T.
So when is the time, right? So we need to find t. So if we are asked to find t, which is the input, output must be given. So what is the output given to us? $0. So $0 is the output, and we are asked to find the input t. Let's take the function one more time. Our function is v of t equals to negative 1000 t plus 12,000. Sorry, it's a 10,000, right? So 12,000 is the original price. So this is our linear equation. Okay.
You had it right. You had it right. It was 12,000.
Oh, okay. 12,000. We are asked to find the time. It means we are looking for this value t. Okay. And in order to find this input, output must be given. V of t is given as a $0. So we substitute $0 for v of t equals to negative 1000 t plus 12,000. Now this is a linear equation. We can solve this. In order to solve, we subtract 12,000 from both sides. So these two cancel. So we have negative 12,000 equals to negative 1000 t. In order to get rid of negative 1000, we should divide both sides by negative 1000. Okay, so this negative 1000 cancel, and negative 12,000 divided by negative 1000, that is positive 12 equals to t. So our time is 12 years. So t equals to 12 years. So after 12 years of purchase of a printer, the value of printer will be $0. Okay. So if you have this depreciation rate, will you prefer to buy this printer? So if you try to sell after 12 years, you may not get any price. Okay. So this is all for this example here. Okay, let me know if you have any question. And like from example 1, 2, 3. Do you have any question from example 1, 2, 3? Okay, one more time. I'm telling you from this section, practice this first, second, third examples. Okay, and for the remaining portion of this lecture, I will make a video and I'll upload on in the link. So you watch the videos and you have to finish the homework by Sunday midnight. Okay, for this section. And if you need help, you can just email me. Okay, now, so let's go ahead and start our review for our exam 3. And if you have any question before that, please let me know. Okay, so it's gonna be page 214 from your book, okay? So this page 214. Okay, so let's start from number 39. So section 2.3. We have a piecewise function here. So this is number 39. So we have this piecewise function. You will see one piecewise function on your exam, okay? You will see. So, and the piecewise function is, so we have negative 2x plus 1, negative 2x plus 1. If our x is less than 0, if x is less than 0, and x if x is greater than equals to 0. So we have this piecewise function, and you are asked to find f of 0. Okay, we are asked to find f of negative 1, f of negative 1. In number C, we are asked to find f of 3, and number D, f of 1/2. You will have to graph as well, so you will need to graph. You should know how to graph, okay? It's not on here, but let me add graph this function. This is like guaranteed question, okay? You may not get the same function. The only difference is that you might have a different function, but you will be asked to find the outputs and you will be asked to graph this piecewise function. It's sure you will have this function, piecewise function, okay? So do not expect the same function, but you will have the piecewise function. Now here in this piecewise function, so we have this output, okay? Negative 2x plus 1 if our input is less than 0. So if you choose x to be less than 0, then you have to choose this expression to find the output, okay? And if your input x is greater than or equals to 0, then your output would be given by this expression, okay? That's what we need to understand. Now for number A, we are asked to find f of 0. Now at first, are we asked to find the input or output? We are asked to find f of 0. Is it, are we looking for the output or input? Output, right? So you have a function of some number, then it's always output, okay? Now if you are asked to find the output, we must be given the input, right? So what is input given to us here? 0 is the input. Now we have a 0. Now is 0 less than 0 or greater than equals to 0? So we have 0 in this set, right? In this set. So the corresponding output is given by this one. So here the function that we're gonna take is our function f of x would be x. Now you substitute 0 for every x. So the function for this is f of x equals to x. Now you substitute 0 for every x. So we have f of 0 equals to 0. So this is your answer. Okay. So for given input, you have to choose the right function, right output. And once you have the correct output, you substitute your input. Okay. Now for number B, we are asked to find f of -1. So it's the output, right? We are asked to find the output, and the input given for us is -1. And where do we find the -1? So -1 is less than 0, right? So we're gonna take this expression. So the function that we're gonna take is, so f of x equals to -2x plus 1. Okay, now you substitute -1 for every x. So you have f of, for x, we have -1 equals to -2 times -1 plus 1. So we have -2 times -2, sorry, -2 times -1, +2 plus 1, and we get 3. Does anyone have question? Let me know if you have question. Now let's go to number C. In number C, we are asked to find the output, and the input given for us is 3. Okay, so you're going to substitute 3 for the correct function. And for this 3, our function is given, output is given by this expression. So our f of x is equals to x. Now you substitute 3 for every x, you get your final answer. So f of 3 equals to 3. So this is our final answer. Now what about f of 1/2? Where do we find 1/2? Is 1/2 less than 0 or greater than equals to 0? Greater than or equals to 0, right? So we're gonna use this second expression to find the output. So we have f of x is x. So you substitute 1/2 for every x. So you have f of 1/2 equals to, your x is 1/2, and this is your final answer, 1/2. You will be given a function. So here, once you know the input, you must choose the correct output. You can't substitute wherever you want. Okay, you will be given an input. You have to know what is the correct output for that given input. Use that function and you substitute your input for every x on your output, you get the final answer. Okay, and the next very important part is graph. Okay, you will be asked to graph. Okay, you will be asked to graph a piecewise function, so you must know how to graph. Okay, now let's graph this function, and let me write the function one more time. So I have f of x equals to -2x plus 1 and x. So this is x less than 0, x greater than equals to 0. Okay, so we have this x-axis, y-axis. We have origin. Now we have the two domain. Okay, so two parts. So our domain is divided into two parts. So we have one x less than 0, and the other portion is x greater than equals to 0. Now let's find out where is x less than 0. Where do we find x less than 0? On the left of y-axis, right? So this portion is x less than 0. Okay, so we're gonna graph this function on this portion, and we have one more, x greater than equals to 0. So this portion is x is greater than equals to 0. Okay, and we're gonna graph this function on the other part. Okay, so we're gonna have like a two different graph here. We have a two output for different input, so we're gonna get the two graph. Now let's start from this one. Let's graph this function. Okay, so in order to have a graph, we need the points, right? Now let's find the point. So we have a function. So our function f of x is equals to x. Okay, so that's what we have. Now let's find the point. So you choose your input x, you find the output f of x, and we get a point x. F of x is the point that we're gonna plot for a graph. Okay, now what kind of input can we choose for this function? Can we choose any real number? No. Okay, that's right. And the reason is that our x, so it does mention here, our x is greater than or equals to 0. So you have to pick a number which is equals to 0 or greater than 0. So what would be the input that you're going to choose at first? So let's choose 0, right? We can choose 0. So if x is 0, what will be the output? So you substitute 0 for every x. So you have x by itself, so we have 0. So 0, 0 is the 1 point. So let me choose x equals to 2. So if x is equals to 2, what will be the output? 2 itself, okay? And if you want one more point, it's easy. So let me choose 4 and we get 4. So we have 2, 2. 2 point is enough, okay? But if you want to add more, it's okay, okay? So this is the table here. Now let's plot these 2 points. So we have 0, 0. So this is 0, 0, okay? Now at 0, okay, next 2, 2. So let's say this is 2, this is 2. So we have 2, 2. And this is 4. And this is 4. So we have 4, 4. Okay, now let me connect these 2 points. So we get a graph here. Now, how far can we extend this graph on the left? On the left, okay? Yes, so our x is greater than equals to 0, okay? So if we extend this graph on the left, our x would be negative, okay? So we can't extend this graph from the left, okay? But since we have equals to 0, so we're gonna have a closed circle. So this graph starts from the origin, okay? And on the right, we can choose any number which is greater than 0. It means this graph can be extended all the way to the left, okay? This is a graph for one part. Do you have any question here? Yes.
So if we're asked to do a graph,
Mhm.
do we use the points that we already used before, or?
No, you can use any point, okay? So like you are not required to choose 2, 0, 2, 4. I mean, you can choose any, but make sure your x has to be greater than or equals to 0. Okay, so you can choose any point. That should be on the domain. Okay, now for the next portion, so we have this function. Okay, so we're gonna graph this portion, okay? So we're gonna graph this portion here. So our function f of x is, so f of x is equals to negative 2x plus 1. So let's make a table. So you choose your input x, you find the output f of x, okay? And x, f of x gives you a point. Now for this case, what kind of number are we allowed to choose? Any number which is less than 0, right? So let's start from negative 1. If x is equals to negative 1, what would be f of x? How do we find that? You substitute negative 1 for every x in this function. So f of negative 1 equals to negative 2 times negative 1 plus 1. And this is positive 3, right? So negative 2 times negative 1, positive 2 plus 1, 3. So we have 3. So negative 1, 3. Now let's choose one more. So let me choose x equals to negative 2. And f of negative 2 is negative 2 times negative 2 plus 1. That is positive 4 plus 1 is 5. So we have 5. So negative 2, 5 is the second point. But you can choose any number that has to be less than 0. Okay, now let's draw a graph. Okay, so here, so we have negative 1, 3. So this is negative 1. So this is 2. So 3 is somewhere here. So we have this point. And negative 2, 5. So this is negative 1. So negative 2 and 5. So this is 4, this is 5. Okay, so here, now let's connect these 2 points and we get a graph. Okay, we get a graph here, a straight line. Now how far can I extend this graph on the right? How far can we extend this graph on the right? So our x is less than 0, right? So we can have x equals to negative 0.001. Okay, so it means you can extend this graph all the way to the right up to 0, not equals to 0. It means at 0 you're gonna have a open circle. Okay, so it means 0 is not included, but any number less than 0, like negative 0.001, that is almost 0 but not equals to 0. Okay, so we can extend up to 0, and at 0 we're gonna have open circle. Now what about on the left? How far can we extend this graph on the left? All the way to the infinite, negative infinity, right? So this is the graph for the next part. Good. And you will have a piecewise function. You will be asked to find the output. You will be asked to graph the function. Yes.
And we also have to find the range and.
No. Okay, so if you are asked to find the range, so here it would be 0 and all the way to the positive infinity, right? We don't have any graph below this x-axis, so the range would be from 0 to all the way positive infinity. But you are not asked to find the range here. Okay, this is the one problem that you will have on your exam 3. Okay, let me know if you have any question. If not, I will go to the next number 44. Okay, let's go to the number 44. So in number 44, we are asked to find the domain and write our answer in interval notation. Okay, function is h of x equals to square root of 6 minus x. So this is our function. So what kind of function is this? So our output has a square root, right? So this is a square root function. We can call it a square root function. And we are asked to find the domain. Now what does it mean by finding a domain? We are looking for a input, right? And our input is x. So we are trying to find the x. Okay, we are trying to list every possible x that give us real output from this function. Okay, and our input is, so we're gonna choose our input from negative infinity to positive infinity. Okay, so this is the option. So we have all real numbers, and from that all real numbers we have to make a list of every real number, okay, which give us our real output through this function. Okay, now this is a square root function. Now what kind of number we can't have under the square root? Negative, right? So if we have a negative number under the square root, it's imaginary number, it is not a real. So we can't have a number. So we have 6 minus x under the square root, right? So we can't have this 6 minus x equals to negative number. But can we have 0 under the square root? Square root of 0 is 0, right? And the next, we can have any positive number under the square root, right? So this is the expression, this is a number that we have under the square root, okay? This number, 6 minus x, has to be greater than or equals to 0 to get the real output, okay? So whatever expression we have under the square root, that has to be equals to 0 or greater than 0 to have a real output, okay? So this is what we're going to do to find the domain. We have the inequality. Now we solve this inequality, and the solution is our domain. Now let's solve this inequality. So solving means we are making x by itself. So we subtract 6 on both sides. So this cancel. So we have negative x greater than equals to 0 minus 6 minus 6. Now we have negative in front of x. How do we get rid of negative? Divide or multiply by negative 1. And when we are multiplying or dividing both sides of inequality, what happens to the sign? It changes, it flips. So we have x, and make sure, okay, do not forget. So if we are multiplying or dividing inequality by negative number, make sure to flip this. So we're going to have less than equals to positive 6. So any number, okay, which is less than or equals to 6 is the domain for this function. Okay, now let's write this in an interval notation. So for that you draw a number line. So we have negative infinity, positive infinity. So we have 6 numbers. So let's say our 6 is over here. Now at 6, are we going to have a closed circle or open circle? Close, right? And having closed circle means 6 is the domain, right? So we are including 6. So we're going to have a closed circle. Now, where do we find a number which is less than 6? On the left or on the right? left. So all this number is the domain. And the interval notation is from negative infinity to positive 6. 6 is a domain we are including, so we're going to have a bracket, and with infinity it's always parenthesis. So this is the final answer, okay, from negative infinity to positive 6. This is the domain for this function. Does anyone have question? Okay, now let's go to the next number, which is 45. So we have number 45, and in number 45 our function f of x is 7 over x minus 2. So this is the function that we have. What kind of function is this? We have a rational, right? So we have our x in the denominator. Okay, so this is a rational function here. So this is our rational function, and we are finding the domain. It means we are finding a number, we are listing every possible number that give us a real output. Now, whenever we have a rational expression, what can't we have? 0 in the denominator, right? So we can't have 0 in the denominator, but we can have any number other than 0 in the denominator. And in the denominator, what do we have? We have x minus 2. So we can't have this expression equals to 0. Okay, now for what x value our denominator is equals to 0? 2. So when we choose x equals to 0, we get a denominator equals to 0. It means 2 is a domain. Is that true? No, right? So 2 is not a domain. But what about every other number? Are those domain? Yes, right? So 2 is not the domain, but every other real number is a domain. So let's write down in our interval notation. So we have a number line from negative infinity to positive infinity, and we have 2, which is not a domain. So we're going to have an open circle. So we are trying to exclude 2. But every other number which is less than 2 or greater than 2 is the domain. So let's write down the interval notation. So we have from negative infinity to 2. Since 2 is not a domain, we're going to have parenthesis. Okay, then from 2 to positive infinity, 2 is not a domain, so parenthesis and parenthesis with infinity. And we have a union. It means we can have a number from first set or second set to be our domain. So this is the domain for this function. Okay, now let's do 47, which is pretty similar. Okay, so number 47, and 47 we have f of x equals to negative 3 over x squared plus 2. Now this is also a rational function, right? And rational function means, and to find the domain we can't have 0 in the denominator. So let's find a number which make denominator equals to 0. Now for this case, for what x values our denominator is equals to 0? So for what x value our denominator is equals to 0? Or we don't have any. That can be also an option. Now if so, we have the negative infinity to positive infinity. So we have all real number, and we are trying to find a number that make our denominator. So this is the denominator that make our denominator, this expression, equals to 0. Do we have any number that makes denominator equals to 0? 2. So if we choose x equals to 2, we have 2 squared plus 2, which is 4 plus 2. We have 6. So that's not 0. Let's try negative 2. That still we get 6. Do we have any real number? So since it's a square, right? So it doesn't matter. So we have a square here. It means if you choose negative number, it makes it positive. So there is no way that we can have a number that makes this expression 0. It means we can choose all real number as a domain for this function. So the domain is every real number. So from negative infinity to positive infinity. So it doesn't matter what number you choose, you always get a real output. Okay? And if we compare these two, so we have this square, it makes so much difference here. Okay? So we have a x square And if you choose any negative number, it always make it positive. So there is no way to have a 0 in the denominator for any number. So all real number is a domain for this function. Okay, let's go. Okay, now for 49, I think you can do 49. It's easy. So 49 is f of x is absolute value of x plus 1. So this is the function. What will be our domain for this function? What kind of number we can choose for x so that we get real number? Can we choose all real number? That's the very first question that you have to ask yourself when you are finding the domain. Can we choose all real number? If yes, then all real number is the domain. So here it does not matter what number you choose for x, we always get a real number. So it means your domain is from negative infinity to positive infinity. Okay, so we have number 50. This is the last function and for finding the domain. So we have our function g of x equals x over x plus 2 times x minus 3. So this is the function that we have. What kind of function is this? What kind of function? If you have your input in the denominator, it's always a rational. Okay, and it's not a quadratic, and their quadratic function looks like this. So f of x is ax square plus bx plus c. So there is no denominator. Okay, so you might have a denominator as a number, but your input is always in the numerator for your quadratic. But whenever your input is in the denominator, that's the rational function. Okay, so this is the rational function. We are trying to find the domain. Okay, and what can't we have for a rational function? While we are finding a domain, we can't have 0 in the denominator. Now, can you tell me the numbers which make the denominator equals to 0? Negative 2 and positive 3. Do you all agree? If you choose x equals to negative 2, we have this expression 0. 0 times x minus 3 is 0. Okay, and if you choose positive 3, this second expression is 0. 0 times x plus 2 is 0. So we can't have negative 2 and positive 3 as our input. But any other number are the domain for this function. Okay, so let's write down that in an interval notation. So we have this number line. Our negative 2 is not a domain and positive 3 is not a domain. So since these are not a domain, we have an open circle. Okay, but every number which is less than negative 2, which is in between negative 2 and 3 and greater than 3 is the domain for this function. So let's write down the interval notation. So we have negative infinity to negative 2, negative 2, 3, 3, positive infinity. So we have union, and this is the domain. Okay, so every real number other than negative 2 and positive 3 are the domain for this function. And you will have at least three different functions, and you will be asked to write down the domain. Okay, so make sure you practice. If you just practice this, and if you make sure you have to understand. Okay, you won't get the exactly same function on your exam. Do not expect same function. Okay, but you will have a similar type, like you will have a square root function, you will have a rational function. Okay, you might have a quadratic function. So you will have a similar function. Okay, but not exactly same function. Okay, so make sure you understand here. All right, so do you have any question before we start the next one? Okay, next here, so let's go to number 52. Okay, number 52, the length of an infant 21 inches long at birth can be modeled by the linear function. So we have this linear function h of t, okay, which is 21 plus 1.5 t. This is the linear function, and this gives us the length of an infant, okay, 21 inches longer, okay, and so this gives us the length of an infant. This is the function. And here our t is the age of the infant. So t is age of an infant. Okay, in months. Okay, the t has to be in months. So it does tells t is the age of an infant in months. Okay, and age of t is in inch. So this is the length. Okay, length in inches. So we have this function, and with the help of this function we can find the length of an infant. Okay, if we know the age of an infant in months, we can find the length of the infant. Okay, so we are asked to find in number A, what is the slope of the line and what does it represent. So this is the linear function, means we get a line as a graph, right? And we are asked to find the slope. And what is the slope here?
1.5.
Okay, do you all agree it's 1.5? So the reason is that our general linear function looks like f of x equals to mx plus b. So this is the general linear function, and the coefficient of your input, so our x is the input and its coefficient is the slope. Okay, in our case t is the input and its coefficient 1.5 is the slope. So here 1.5, m is 1.5. Now what does it represent in this specific example? So what does 1.5 represent?
Change each month. The length.
So as the time changes by 1 month, the length changes by 1.5. Now does the length increase or decrease? It's positive, right? It's an increase. Okay, so the it tells us, it gives us the length. Yeah, like as the time changes by 1 month, the length increases by 1.5 inches. Okay, in number B, we are asked to find what is the length of the infant at 6 months. So what is the length? It means what are we asked here? Are we asked to find the t or h of t? So we are asked to find what is the length of the infant. It means we are asked to find h of t, right? So we need to find h of t. And if you are asked to find the output, input has to be given. Okay, and input is 6 months. So your t is 6 months and you are asked to find h of 6. So which is given by this function. You substitute 6 for every t. So we have 21 plus 1.5 times 6. So this is 21 plus 1.5 times 6. That is it 9? Okay, so we have 30 inches. So the infant will be 30 inches long after 6 months. So when you have the old problems, the very key thing is that you must know what is given to you, and you must know what you are asked to find. Okay, and the remaining is substitution. Okay, in section 2.4, so for the 54, 57, you are asked to find the domain. It's pretty similar. Okay, and 61, you are given a graph and you are asked to find whether it's a function or not. And what do we use to find the function or not? What kind of test do we use? Vertical line. Okay, so there is a 2 tests. Do not get confused. So we use vertical line test if you are asked to find whether a graph is a function or not. And if you are asked to find whether a graph is a one-to-one function, then we use a horizontal line. Okay, if the vertical line crosses 1 point, it is a function. If a horizontal line crosses exactly once, then it is a one-to-one. Okay, so let's do this much for today. Remaining we will do tomorrow. And if you have any question, I'll be here for a few minutes. If not,